Okay, this video is for section 3.3 and it's applying trigonometry. Um, so in the beginning, step one is draw and label diagrams. So in this triangle, calculate the area. So we need to draw the triangle. Call this A, B. AB is 6.5. BC is 4.2. And BCA is 65.6 degrees. It says calculate the area of the triangle. I feel like they're missing. So my gut wants me to do, I guess I'm gonna have to figure out this third side. Or figure out this angle. Let's figure out that angle using the law of sines. So now I've drawn the triangle. I know three parts. If I want to do area of a triangle, 1/2 AB sine C, I need the angle between them because this would be A. This down here is B. I don't know that. C. So effectively, I can change the letters. 1/2 AC, but then I need the angle between them, so sine B. So I can do this, however, by using the law of sines. 6.5 over sine 65.6 equals 4.2 over sine A. A should be an acute angle that is shorter, so this should be fine. 6.5 sine A equals 4.2 sine 65.6. I shall divide both sides by 6.5. And then I'll take the inverse sine. So inverse sine 65.6 over 6.5. And I grab my calculator. And I get A is 36 degrees. 36.0. So B, I'm just going to do 180 minus those two. And get 78.4. The area is 1/2, two sides, 13.4. The units were in centimeters, so this is centimeters squared. Take a look here for just a second, make sure that they think the same. Got the same thing. They used the law of cosines. I guess that could get you this side. That could get you this third side. Yeah, it seems a lot harder to solve though with two, because you end up with a quadratic. You do have to be careful though that you weren't solving for an obtuse angle that was potentially obtuse. You probably really need to use the law of cosines. Okay. ABC is a CD is a quadrilateral with the following side lengths and DAB 90. Find the area of the quadrilateral. So I gotta draw this. A B is 40. Actually, there's a 90-degree angle at A. Let's make this vertical line. This is A, this is B. That's 40. AD is 30. That's 90. BC is 50 and CD is 71. And it says find the area of the quadrilateral. I can cut it in half and do two triangles. It's probably going to be the easiest thing. So the area of this first triangle is 1/2. It's a right triangle. 30 times 40. 1/2 base times height. 600. This next one is where it gets tricky. This diagonal here is 50. I did know that that was pretty straightforward because 3, 4, 5 right triangle on ABD. I can, couple ways I could do this. I could find the angle using maybe law of cosines, or I can recognize this is an isosceles triangle. These are, those two angles are equal. Um, and so I can draw a height right down the middle. It's going to split the 71 in half, 35.5. And I guess I don't even need the angles. I can get the height with the Pythagorean theorem. So these are IB type of triangle problems. Just got to do a couple extra steps, figure intermediate things out. You could find those angles with law of cosines. It just seemed a little bit harder. So I get H equals 35.2. My second area is 1/2. Base is 71. Height is this 35.2 that I just found. So we'll call this A1, A2. And 2 equals 1,250. Actually very close to that too. So a total, I add them together, 1,850 units meters squared. Important when labeling these polygons, A, B, C, D, A has to follow B, then C, D. And it doesn't matter which way you go, clockwise or counterclockwise, just so you choose one. Yeah, they totally did the reverse. And totally got the same answer. Oh, correct to one decimal place. I need to read the directions quick. This was 149, so it was 1249.96. The six is going to round up, so that actually is still the same number. Always make sure to read the final directions on rounding. If it specifies, it's worth a point. Solving problems by sketching diagrams. Find the distance without actually measuring. And the key to this is going to be using trig. This is used commonly in surveying, finding two measurements that you know, and then using trig to find the others. So triangulation, this used to be a very common thing. And it's still used by people that do surveying. So in the picture above, the river surveyors in France are using triangulation to find the width of the river Seine. I think this goes through Paris. Angle D, D right here is 82, it says. See if I can get these in the same. This is D. Let's do red. It'll show up better on the picture. 82 degrees. Length of the base DA is 10 meters. And the angle A is 90. Says, what is the width of the river to the nearest meter? So I think they're looking at the hypotenuse. Um, so I'm going to do a sine. I don't know for sure. This isn't a very well labeled diagram because I think some of this is in French. So sine of 82, nope, that's a cosine. Should be using a cosine that's adjacent over hypotenuse. Cosine of 82 equals 10 over h. So multiply both sides by 8, divide by cosine 82. And the hypotenuse is 10. I can do opposite with a tangent. Since I don't know which one for sure, I'm gonna do both. Opposite over adjacent is 10. So this becomes 10 times tangent of 82. Opposite equals 71.15. So to the nearest meter, 72 meters or 71 meters. I'm not sure which one they're asking for. So let's take a look at the. Okay, be aware the perpendicular distance is not the hypotenuse, it's the shortest distance. Okay. 71 meters, the width is whatever is the shortest. So 71 meters. So here we have a more complicated one. Land surveyor measures the initial angle to a distance tree at 67 degrees. She walks 5 kilometers and measures the angle of the same tree at 36. She measures some other angles. You can see her sketches. Find the distance between the two landmarks B and D. So first thing I want to do is get this side right here. We're going to get X and Y. So in order to get that side, I probably need to use law of sines. And let's get that angle by doing 180 minus the other two. So 180 minus 67 minus 36 gives me this angle is 77 degrees. We'll do the same thing over there. 180 minus 49 minus 30 is 101 degrees. So first thing, X. So sine 77 over 5 equals X over sine. Oh, I should just do this the other way so X is on top. So you can flip these ratios however you want. 5 over sine 77, as long as your sides are both the same and your angles are both in the same spot. Sine 67. So I'll multiply both sides by sine 67. And that will equal X. Do some basically the same thing for Y. 6 over sine 101 is the angle. It's not written super nicely. Equals Y over sine. Angle across from that is 30. So 6 sine 30 over sine 101 should equal Y. Y equals 3.05. Uh, I should round that correctly, 3.06. Now I need to use, probably the easiest way to do this is law of cosines. 4.72 squared plus 3.06 squared minus 2 times 4.72 times 3.06. Now I do have all these cosine 113. So it's a little hard to see the cosine of 113, but it's this angle right there. And I'm going to take this and put it in my calculator. And I have the numbers in my calculator, so I'm using more decimal places than one of them I can use previous answer for. And this gives me X equals 6.55 kilometers. It says round to the nearest kilometers. X equals 7 kilometers. Okay, when you're done watching this at the end of 332, watch the video for the theory of knowledge connection on maps. Let's talk about bearing. Bearing is set as compass directions. It's measured clockwise from due north. It's always measured this way. And they give some of these things. These are always bearings. So bearing of 74 looks like what's shown in the picture here. So, to draw a picture, a ship leaves port traveling 40 kilometers at a bearing of 40. So we start by drawing a picture. North, south, east, west bearing is 40, and it's going 40 kilometers. It then continues to travel another 70 at a bearing of 120. So I put another one here, essentially, and I get 120. I guess I don't really need the whole thing. Goes 70 kilometers. How far is the ship from port? Okay, so this is 40. That means this right here is going to be 40. And that's 60. So 120 plus 60 gives me 180 straight south. These two right here are alternate interior angles between vertical lines. So effectively, I've got a triangle 40, 120. No, 70. Why do I have a 1 in front of that? I don't know why there's a 1 there. It's not an angle either. This here is 100 degrees. It says how far is the ship from port? That would be this distance right here. This is a straight, simple law of cosines. Now that I've gotten the angle, the hard part is finding the angle. I plug it in, I solve for x. It does not specify, so 3 significant digits. 86.4 is what it's going to round to, kilometers. So now we have a ship sailing from an island 30 kilometers on a bearing of 100 to reach point B. At point B, it travels 23 kilometers to point C. Find the distance AC. Oh, if the angle is 79, find the bearing of C from B. So it's this bearing right here. So again, I can use my alternate interior angles trick. This is 100, which means the bearing is going to be this, which is 180 plus this little angle in here. This part is 180. This little angle in here is 100 minus 79, so 11. So that's a 100 bearing of 191. Find the distance A to C. This is just, again, a really relatively easy law of cosine problem. And we get 34.1 kilometers. So finding the bearing was actually the hardest part. I got 201. Oh, what's that? Okay, 100 minus is 21. That's 21 degrees, not 11. 201 degrees. They did it a different way. They found theta is 80, added 79, and then subtracted from 360. Well, so another valid way to do it. So they have this written down, and then that's metal line. So let's see that. Going back. Angles of elevation and depression. Can you guys be relatively quiet? You can talk quietly, but thank you. So angle of elevation and depression measured down from or up from the horizontal. They are equal. They are alternate interior angles, but it's important that they're measured to the horizontal. The world's second tallest tree is in our Valley, Tasmania, Australia. It towers above the trees around it. It is 99.82 meters tall. Forest surveyor is measuring the heights of other trees in the region. He measures the angle of elevation from his eye level to be 81 and the distance to the foot of the tree to be 8. His eye level is 1.58 above the ground. 81 degrees. This is 1.58, so I'll have to add that at the end. I'm looking for the height here, x. So that's a tangent. Opposite over adjacent. So 8 times tangent of 81 is 50.5. And I'm going to add 50.51. So now I add my 1.52. No, 1.58. And I get 52.09 meters. It asks for it in centimeters, so 5209 centimeters. And there, yes, they got the same thing. So here we have the eagle sits on top of a tree, the edge of the ocean watching a fishing boat. The angle of depression is 24 degrees and the tree is 47 meters. Alright. How far is the fishing boat from the eagle? That's a hypotenuse. And then the second one asks me for y. So if this is 24, I also know that that is 24. So I could use a sign here. Equals opposite over hypotenuse. So I'll multiply by x and divide by sine 24. And I get the distance from the tree to the fishing, or from the eagle to the fishing boat is 115.5. S foot to the nearest meter, 116 meters. How far is the fishing boat from the tree? I feel like Pythagorean theorem. Minus six. Y was then 106 meters. Last thing, there is a video on making connections of how does math guide our ships. Go ahead and watch that when you have a chance. Um, and if you feel like it, you can look through this last example. Similar idea. Distance B to C, you could just use um, uh, law of cosines. The height of the control desk. The diagram shows the air traffic controller starting and two runways. So this one is actually a vertical height. The start of runway one is at point A, the start of runway two is. So it gives you some horizontal distances. The height of the control desk above the ground, you would just use a tangent. The angle of depression from the start of runway two to that. So so here I have my distance and distance. So it's to find the angle of depression, I would essentially find that one using an inverse tangent between my two heights. Notice how many decimals they're carrying until final answers. And then part D is related to, is planting grass to make the airport feel more welcoming. The triangle ABCD needs to be seeded. A seed of grass covers weighing 10 kilograms costs that much, this much area. So you calculate the total area, which you can do with 1/2 AB sine C. I calculate the area and get this much area divided by the area each bag covers. So you need 33 bags. Multiply 33 by the cost of each. So they did the area and got that, just 1/2 AB sine C divided by the area each bag covers. Get that. You have to round that up because it must be enough. Multiply the 33 by the cost of each bag. And there's your final cost. Okay, that is 3.1 through 3.4 applications of trigonometry.